Hello, and welcome back to DataFlowLytics, your guide to mastering the world of data engineering. Today, we're going to explore one of the most fundamental concepts in data engineering, ETL, extract, transform, load.
Okay, so let's just dive right in. Before we can even talk about the solution, we've got to understand the problem. Why is it that companies are collecting these just mountains of data, but so much of it in its raw state is practically useless?
Well, the short answer is chaos, pure and simple. Think about it. Data is scattered all over the place, in different databases, various cloud apps, you name it. It means it's often isolated, the formatting is totally inconsistent, and it's just plain messy. Trying to get any real insight from that is like trying to build a puzzle with pieces from 10 different boxes. It's just not going to work.
So, how do we bring order to all that chaos? Well, that's exactly where ETL comes in. It's the structured, methodical process that data engineers like us use to tame all that wild data and actually make it valuable.
At its core, ETL stands for extract, transform, and load. You can think of it as the workhorse, the engine that takes data from all those different, messy sources and gets it ready for prime time, making it clean, consistent, and ready for analysts and data scientists to work their magic.
It's really just a simple but incredibly powerful three-step dance. You get the data, you fix the data, and then you put the data where it needs to go. Extract, transform, load. So, let's break down that very first step, extract.
First up is extract. This part is all about collection. The goal here is to just go out and gather all the data we need from its original home. And it doesn't matter where it's living, whether that's a traditional database, an API, or a bunch of log files. The extraction process pulls it all together for us.
Now this is where the real magic happens, the transform step. Once we have all that raw data, we have to clean it up. I mean, some studies show that data scientists can spend up to 80% of their time just cleaning and preparing data. This step is why. It can mean anything from filtering out junk to standardizing formats, like making sure all your dates look the same, or even joining data from different sources to get a richer picture. This is the crucial step that adds the most value, for sure. And finally, we load. After all that hard work, we need a place for our shiny, analysis-ready data. This destination is usually a central repository, like a data warehouse for really structured data, or maybe a data lake for more flexibility. The point is, this is where it becomes easily accessible for reporting, for business intelligence, and for training machine learning models.
So we get the process, but why is it so important? I know, calling ETL a superpower might sound a little dramatic, but for any organization that wants to be data-driven, it really, truly is.
I mean, fundamentally, ETL is what creates a single source of truth by combining all your data. It enforces rules to make sure everything is high quality and consistent, because without trust, your analysis is worthless, right? This is what gets data ready for the cool stuff, like advanced analytics and ML. And the real game changer? It automates this entire workflow, letting you process massive amounts of data efficiently and reliably.
Now, of course, we're not building these powerful data pipelines by hand. There's a whole ecosystem of tools and technologies out there designed specifically for ETL. So let's take a little peek inside the modern data engineer's toolkit.
The options are pretty vast depending on your needs. You can use powerful open-source frameworks like Apache Airflow to schedule really complex workflows. Or you can just lean on managed cloud services from AWS, Google, and Azure, which are incredibly scalable. And for maximum flexibility, a lot of engineers, myself included, build custom solutions using programming languages like Python with amazing libraries like Pandas or PySpark.
Knowing the tools is one thing, but how do you actually go about building a robust ETL pipeline? Well, it requires some careful planning and a clear understanding of the entire data journey, from beginning to end.
Yeah, building a great pipeline always follows a structured approach. You have to start by deeply understanding your sources. Then, you define the business logic for all your transformations and choose the right destination. You schedule the pipeline to run automatically so the data stays fresh. And critically, you have to build in monitoring and error handling, because in the real world, believe me, things can and will go wrong. To make all this a bit more concrete, let's just walk through a really simple conceptual example of what this might look like if we were using a language like Python to build it. Okay, so imagine we have a simple CSV file with sales data. The extract step is just reading that file into our program. Easy enough. For the transform step, maybe we find some rows are missing a sales figure, so we just clean those out.
And finally, the load step could be as simple as saving that cleaned up data to a new file or popping it into a database table. Extract, transform, load. That's the core loop. And that really brings us to the key takeaway here. ETL isn't just a technical process, it's a foundational skill. Understanding how to effectively move, clean, and structure data is what separates a good data engineer from a great one. Mastering this opens up a world of possibilities in analytics and big data.
So, I'll leave you with this question. Every organization has data locked away in messy, siloed systems, just waiting to be turned into valuable insights. Now that you understand the process that makes it all possible, what data will you unlock first?